Welcome to Trig Functions and Right Triangles. So today I'm going to refresh your memory of some things that we spent some time on in geometry. Remember, when I say trig, we're talking about SOHCAHTOA. So a refresher of our ratios, we have sine, cosine, tangent. So if we're looking here at this triangle, remember this symbol is theta. So your sine is your opposite over hypotenuse. So if you remember, if here is your theta, that's the angle we're looking at, your opposite is going to be on the other side of the triangle. So for this theta, here is your opposite, and your hypotenuse is always the side that your right angle points towards. So there's your hypotenuse, and then your adjacent is the one that's left. So it's always according to this theta that they want. So remember, your sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Remember, we use SOHCAHTOA to remember what sides we need for this, where S is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first letters of spelling out SOHCAHTOA tell you which trig function and which two sides that you need. Now the new one that we're going to talk about this year is what we call our inverse trig functions. So remember, inverse means we flip them upside down. And these we have cosecant, secant, and cotangent. Your cosecant is the inverse of your sine. So we're going to put inverse of sine. Your secant is your inverse of your cosine. And your cotangent is inverse of the tangent. So basically, once you find sine, cosine, tangent, you do the inverse of each of those answers, and that's your cosecant, secant, and cotangent. So they're just three new trig functions for you to remember. So all we're going to work on today is trying to find the values of all 6 trig functions. So let me zoom in on this triangle so you can see the numbers. So I want to find the 6 trig functions of this triangle. But what you need to notice is I am missing the length of one of these sides. So because this is a right triangle, in order to find the length of that third side, we have to do Pythagorean theorem. If you remember, Pythagorean theorem is your a squared plus b squared equals c squared, where c is your hypotenuse. Again, your right angle points toward your hypotenuse, so in this case 25 is my hypotenuse. So I'm going to do a squared plus 7 squared equals 25 squared. So it'll be a squared plus 49 equals 625. Remember, to start solving for a, I have to subtract the 49 from both sides. So a squared equals 576, and then I'm going to square root this, which gives me an exact answer of 24. Now, if it did not give you an exact answer, I would expect you, since we know how to simplify a radical now, use the simplified radical form, as in make the tree, pull out your pair of numbers. So you may have a square root in our answers. So if we want to evaluate the 6 trig functions of theta, I did forget to put this in here. We're going to use that as theta down here. So we're looking at angle A. So the easiest thing to start with is, if this is angle A, I want to label the opposite adjacent the hypotenuse. So if here's my theta, on the opposite side of the triangle is 7, so I'm going to label that OPP. My hypotenuse I know is 25, so I'll label that HYP, and then 24 is my adjacent. Remember, SOHCAHTOA. So I'm going to start with sine of theta. Let me move this over. Okay, so sine of theta. We have the O and the H, remember, which is opposite over hypotenuse. So my opposite is 7 over my hypotenuse is 25. Because this is a fraction, we need to remember all of our rules of fractions. If you can reduce it, reduce it. If there is a radical in the denominator, you must rationalize it. So that's something to remember for your homework. Okay, so if we have cosine theta, cosine is adjacent over hypotenuse. So my adjacent in this case is 24. My hypotenuse is 25. So cosine is 24 over 25. And then tangent is opposite over adjacent. So my opposite is 7 over my adjacent is 24. For my other three trig functions, I just remember which one matches up with what. So we have cosecant lines up with sine. So it's the inverse of that. So instead of 7 over 25, we have 25 over 7. The secant lines up with the cosine, and instead of 24 over 25, we have 25 over 24. And then my cotangent lines up with my tangent and now turns into 24 over 7. And all of that is the solution to the problem. Let's try one more. Same type of problem, worded differently. Let me zoom out here. So we have sketch a right triangle that has theta as one of its acute angles, then find the values of the 5 trig functions not given, and tells me the cosine of theta is 5 over 7. So I'm going to draw me a random right triangle over here. And I'm going to label this theta. Now if it gives me the cosine is 5 over 7, if I remember SOHCAHTOA, cosine gives me adjacent over hypotenuse. So if I'm looking, here's my theta, this is my opposite, there's the right angle, so here's my hypotenuse, and here's my adjacent. So that means that the 5 represents the adjacent, and the 7 represents the hypotenuse. So my adjacent's here, I'm going to make it 5, and the hypotenuse is 7. So now it's just like the last problem. We still need to find the opposite side here. So we have to use Pythagorean theorem. Again, C is my hypotenuse, so I can start with a squared plus 5 squared equals 7 squared. A squared plus 25 equals 49. Subtract 25. So a squared equals 24, and then we would have to square root that. Well, 24 is not a perfect square. So we're going to go ahead and we're going to simplify this correctly. 24, remember, breaks down into, let's see, 6 times 4, so 2 times 2 times 2 times 3. We have a pair of 2's, so it breaks down into 2 square root of 6. So we're going to use 2 square root of 6 as the opposite side. Now what that does mean is we may or may not have to do some rationalizing. Let me write down my 6 trig functions. Sine, we already have cosine, so we need tangent. Then we need cosecant, secant, cotangent. I know my secant is the opposite of the cosine, so since I already have 5 over 7, I'm going to make it 7 over 5. Sine is opposite over hypotenuse. So my opposite is 2 square root of 6. My hypotenuse is 7. Again, I have to look and see if I can reduce, but 2 over 7 does not reduce, so that's my sine. My tangent is opposite over adjacent. So my opposite again is 2 square root of 6 over my adjacent is 5. Now we're going to run into a small problem when I do my inverses. Because when I flip 2 square root of 6 over 7 over, I have 7 over 2 square root of 6. We need to remember that you cannot have a radical on the bottom of a fraction. So in order to rationalize, I have to multiply the top and bottom by square root of 6. So it turns into 7 square root of 6 over, remember this is 2 times 6, so that would be 12. Cotangent, we're going to have that same problem where it turns into 5 over 2 square root of 6. So multiply top and bottom by square root of 6. So that gives me 5 square root of 6 over 2 times 6 again, which is 12. And all of that is my answer.